Downtime costs serious amounts of money, but effective condition monitoring can make a big difference. Well, today we get the chance to revisit Omron to find out how they are helping their customers to save money. So now we're into the Omron area. I've found Dave and we're going to look at this subject. Now, Dave, we've touched on condition monitoring before. It seems to be getting more and more important for companies now. Why is that?
Certainly, I mean, unplanned downtime has always been an issue, but it's becoming more and more important, if nothing else than because of the cost. You know, the average cost of unplanned downtime in the UK is a little bit over £5,000 an hour, but that obviously scales with your business. So, you know, if you were a pharmaceutical clean room, it might be 25,000 if you've got to sterilise the room. If it was a car plant, it might be 5,000 a minute. In addition, there's also the timescales involved. So typically, on average, in a British factory, it's about 19.2 hours a month of unplanned downtime. You know, you can add that into the 20 hours a week that you would have with planned downtime, and you can see that that comes to some considerable costs. Yeah,
those figures are quite astounding, really. So, Omron have some offerings in this area. Take us through some of the bits that Omron can help.
Yeah, certainly. I mean, we broadly look at a number of fronts. The first thing really to talk about is protection of electric motors and what we call condition monitoring of them. Electric motors tend to be a device that runs 24/7. It's what runs your fans, your pumps, your conveyors, cooling systems. So if they go down, it takes down the entire process. What we have is an edge-based computing system. So essentially we have motor monitors that sit within the control panel. So it doesn't get involved with your existing architecture, it sits on the top of it. And we basically have 3 units here. And these units will essentially replicate what you would have in preventative maintenance from a maintenance engineer's point of view. So we can look at vibration and temperature, which is simply done through a probe on the motor itself, and that will, if the motor starts to have any issues, it will start to shake, for example, if the load's misaligned, or if it starts to get hot. We can also do what we call current analysis. So that's using a current transformer, and it's actually measuring the waveform of the supply to the motor. That's a very clever technology because that allows us to essentially not only pick up a fault with the motor, such as a bearing breaking down, but we can also check the condition of the load attached to it. So we can see if perhaps a load's misaligned, if a submerged pump might be cavitating, for example. So we can get a lot of information on there, and we can pick up a fault long before it starts to heat up or vibrate the motor. And then the third check that we can do on a motor is we can essentially automate the insulation resistant checks. So in a motor, you have a rotor and a stator, and the insulation on the windings breaks down over time. Traditionally, that would be done by having a skilled maintenance engineer put a mega across it. We can now do this while the motor's running through a CT, or if it's not running through another unit, which just squirts 50 volts in. So that essentially, you know, rather than it being checked maybe once every 2 years, we can now check it every hour, every week, every month, and it can be done remotely.
So here we are, Dave. We're at the panel now. Omron have a fantastic reputation with control panels. There's a lot of products on show here. Could you take us through some of the highlights?
Well, condition monitoring within the panel is generally done on a device level. And as you said, there's a lot of products in here. It could be something as simple as, for example, on an inverter drive, you know, monitoring the IGBT packs. But to give you an example in here, if we looked at the power supply side, you know, here we have a couple of power supplies with a redundancy unit. So if one of the power supplies goes down, obviously it will swap over. We have an electronic circuit breaker. So essentially that's between a 4 and an 8 channel equivalent to an MCB. The beauty of that is it will give you a warning before it trips, and also it can be remote reset. So essentially you can reset the machine from a central point or even the machine builder. We then have an intelligent power supply. So this is called the S8VKX. Now obviously if the power supply goes down, it takes down the entire panel. So this has an Ethernet port on the front, which lets us get a lot of data out of it. We can see the runtime, the current, the voltage, the lifespan of the unit, for example, as well. So all these kind of diagnostics are very simple devices, but basically they can be added together to build a picture of the health of your panel. For non-intelligent components, we also have a series of essentially thermal cameras. So this thermal camera mounts inside the door, and it can be used to monitor the individual temperature of each component within the panel. So, you know, a safe temperature, for example, for a transformer could be different to what you'd expect for a PLC. Right. So you can measure these individual temperatures, you can measure the rate of change, so you can alert if it's starting to reach its high temperature. And this gives you, again, a nice tool really for detecting any unplanned downtime before it happens.
That's fantastic. As we said, there's a lot of product on offer here. So obviously for viewers that are looking at the panel at the moment, they maybe see something. The best thing is just to get in touch with you?
Certainly, yes. Yeah, get in touch. We have a lot of information on the website, and our sales team will be happy to help as well. And we have a Monday to Friday technical desk as well.
Okay, that's brilliant. Thank you. So Dave, I understand that Omron have got something new to show us.
Yeah, this is a brand new family of laser time-of-flight sensors that we have called the E3SHF. It's essentially a 6-meter laser sensor which works up to 95-degree angle and is totally immune to changes in surface finish or colour. Now, sensors are becoming increasingly important to machine uptime because essentially that's the eyes and ears of the machine, but that means they're generally in the field, so they can be affected by dust or dirt, or maybe in a food factory it could be cleaning chemicals or product building up. The E3SHF is designed to mitigate a lot of these problems. It's IP69K, so it's designed to be jet washable and waterproof. It has a oleophobic coating on the front, so that stops dust, dirt and moisture, for example, adhering to it. It's designed essentially to resist cleaning chemicals, so like Ecolab and Diversi. So if you have a high care environment where they may be washing it down regularly or steam cleaning it with an acid or an alkali, we have an air blast that you can fit to the front of it, which again will keep it clean. It even has a heater inside, which allows you to use it in chillers and freezers down to -30. So it's got very, very strong environmental resistance. In addition to that, all of Omron's PMP sensors now have IO-Link. Now, IO-Link is essentially a point-to-point protocol, but it lets us get a lot of data on the condition of the sensor into the PLC. So here we have a simple setup that's reading some of the IO-Link data, and we can see the firmware of the software, the manufacturer, the serial number. This is quite important because, say, if you have a sensor fail in the field and someone plugs a new one in, the PLC can recognize that, and then it can send all the parameters to it, essentially de-skilling the setup of the sensor. They just plug it in and it'll set the switch point, etc. Also, within the software there, and this is the unit on the side here, we can set the switch point, but we can actually see the light level coming back. So again, if that started to get dusty or dirty, for example, we can get a warning through the sensor before the actual switch itself finishes. And again, we have some other sensors attached to here. So this is an E2E Next, which is a simple proximity switch. But again, rather than switching on and off at a switch point, we can essentially set it so that we can have a too near or too far alarm. So again, if the part it's detecting starts to drift too close and might damage it, or too far away, again, it can give us a warning so we can adjust it before it stops the machine.
Right. It's really good. So in terms of these products' availability, is it something that people can talk to you about now?
Yes, these are in stock now, and they're available through our distribution partners and the national ones in there as well. And again, we've catalogued some white papers up on the website, and if you need any questions at all, give us a call. Also, our field application guys and our sales guys have got kit in the field, and they're quite happy to come to site and have a look at applications. So for unplanned downtime incidents that haven't been detected by, say, smart components or motor monitoring or intelligent sensing, we can also offer a system called Automation Playback. And this runs on our NX5 series of controllers. Think of it as a black box for your machine. It basically lets you record status and data for 15 minutes before a failure and 15 minutes after. This, what you're seeing on the screen here, is Sysmax Studio, which is our IDE, our integrated development environment, and this shows some of the diagnostics that you can get. So for example, you could record video, so you could see what's happening on the machine itself, whether it's a bottle filler or a rotating table. We can see the status of the ladder logic, so you can interrogate that. And we have the trace functions on there next to you, which we can see, for example, inputs, outputs, analogs, etc. This is really important for a number of reasons. For fault finding, it could be an intermittent fault. So rather than having to wait for it to occur multiple times to detect it, you can scroll backwards. From a machine builder's point of view, they can dial in and remotely diagnose an issue on the machine itself. And it can even be used for operator training. So, for example, so if it was maybe misloading of a part, you can use that video then to train your operators not to cause the same issue again.
That's fantastic. That's really a practical approach to this. Now, for people watching this, unplanned downtime, as we mentioned, is clearly a costly item. Where do they start, Dave? Where's their start point with this?
Well, as we discussed with looking at some of the other components, start small. It could be something as simple as picking 2 or 3 motors and putting a condition motor monitor onto it. It could be using some smart sensors. It could be looking at something like Automation Playback. On the Omron website, we have a wide range of resources. We have catalogues, manuals, white papers on condition monitoring. And obviously get in touch with us. We have a Monday to Friday a tech support desk, and we have field application engineers that can come to site and show you the technology as well.
Absolutely brilliant. Thank you so much. Well, if you've been watching this and want to find out more, we of course will post all of the links. Thanks ever so much for watching, and we look forward to seeing you on the next video.